Hi guys, good evening. Am I audible to everyone? Yes. Let me open up my screen and start sharing the screen. Yeah, let me know once you're able to see my screen, guys. So, the program is visible to you all. So today is our day 8. I'm a new package, day 8. And we are going to program this. Okay, we had written the code yesterday. Okay, we had written the dummy code over here. So we'll now actually implement this. So let's try to implement that with you guys. Let me know once you are able to see my Eclipse screen. Yes, is it visible now? I'll make a new class. It is visible, right here. Okay. So I'll call it use word. And I'll finish. That's the question which we were referring. So let's check that out. Okay, somewhere we had it. Yeah, priority queue exercising, right? On day 6. Let me fetch that from day 6. From day 6. This is the question, right? I'll just share. Okay, so this is the question which we are solving. And let's try to code this right now. So in the main, what will I accept on the user? I'll have a scanner class. And I'll ask the user to enter the number of 3 juices. Enter the quantity of apple juices. Just again to juice 1. Let's see out next int. And enter the, that will be juice 2. And let's say banana, that will be juice 2. Okay. And I will call a function will calculate the minimum time, passing these 3 to it. And once I get the min time, I'll say something. Minimum time is these many. So let's create this function. Now I'll push all of these into a priority queue. So let me take a priority queue of integers. Okay, I'll call it PQ. And we'll do it in the reverse order because you need to fetch the maximum juice first. So we have collections dot reverse order. And now I'll add all of them to PQ dot add juice one. I've added all the juices to the priority queue. Okay. So I've added all the three juices to the priority queue. Okay, so now my queue is looking somewhat like this. Let me share my screen along with the. Okay, so what should I start with? You should start with 544. So now my queue has 5, 4, and 4. Okay. Queue has 5, 4, 4. Okay, while my queue is not empty. Yes, so 544 means the queue is not empty. Okay, I'm constantly flipping between the three screens. Okay, so just let me know if what I'm trying to tell and show is not in sync. So I'm back to the Eclipse screen. So what will I do? I'll take an integer second also. Initialize it to 0. And now I'll start my iteration. Okay. So while, what do I do? While my PQ is empty. Okay. And I'll give a not, means while my PQ is not empty. So now my PQ has 5, 4, and 4. So PQ is not empty. Okay, and I'll initialize the J1, J2 inside every time. J1 as 0 and J2 also as 0 in each iteration. So J1 and J2 also will try to play around. This is 0 and this also is C. Now, if my priority queue has elements, okay, as I said, so how do I check that? So for that we have a iterator. So we can apply that on the priority queue, which will help us to know whether the queue has more elements or not. So I'll call it ITR, and I will add this iterator to the priority queue. Dot iterator. And take it on the util. So now using this iterator, we can check if my ITR dot has next. So are there elements in this? Yes. So what do? You do a PQ dot remove and you store it into J1. Okay. So what will come in? So this will be removed maximum one because we are operating in reverse order. So this is my PQ. And my J1 now becomes 5. So after removing of this, do I still have more elements? I will check. Does it have elements? Yes. Again, do a remove and put it into J2. So it will remove 4 also and put it into J. Now, if I have only one type of juice, so if it was only 400, If it was 4, 0, 0, then what would come? I would have 4 over here and 0 over here. So if my J1, okay, as I mentioned over here, if my J1 is greater than 0 and J2 is equal to 0, I'll, if my J1 is greater than 0 and my J2 is equal to 0, what do? I directly add to the seconds J1 and I break the loop because there are no more left. So right now, if I have 5 and 4, okay, if I have 5 and 4, is 5 greater than 0? Yes. And is 4 equal to 0? No, false. So it will not go in this if condition. This if will not be true. So now let's go ahead. Okay. So this is, oh yeah. Now if both are greater than 0, then so here both are greater than 0. Then what do? If J1 is greater than 0 and J2 also is greater than 0, then I increment the seconds by 1 and I reduce both of them by 1 each. Okay. And now if both, I'll check if there's still more juices to be made of type J1, I'll push it back. So if J1 is greater than 0, I'll add it back to the PQ. And if J2 also is more than 0, I'll add it back to the X. And now this will keep on going till my loop terminates. And once my loop terminates, I will return the seconds. As simple as that. Okay, so while my queue is not empty, loop will keep on continuing. Once my loop, either it breaks organically or I have written a break over here. Whichever ways it breaks, I will return the seconds value, which is the integer, and return and display over here. So let's try to run and check this code if it is working as per our expectation. So for the first trial set, you have to enter 544. 544. And it says minimum time 7, which is absolutely correct. If I enter 300, let's check that out. 300. It says minimum time 3. That also is correct. And if I enter 142, let's check that out. 1, 4, and 2. It takes minimum time 4. That also is correct. So this was one of the program which I wanted to solve on your priority queue. Is that making sense? So stacks and queues, you all should be very much comfortable, and they are asked a lot in your interview questions. So practice as much as possible various scenarios using stack and queue. Okay, all good. Let me just check on what's happening at the YouTube front. All good, guys. Those who joined through YouTube, are you all able to understand? And are you all trying to do pair programming with me? Yash, Junaid, and these guys. So let me push this code to GitHub now. Yes, I'll push it to GitHub. Just give me a second. I will try some more exercises. Okay. And one of the many uses of stack is your infix to postfix conversion and evaluation. Okay. So those who are study data structures, they might know what is infix to postfix conversion and what is the evaluation. So we have three types of expressions. So now we are into application areas of stack. Okay. We will try to solve some programs on that. So among the other applications is we have three types of expressions. Infix expression. Okay. I hope you are able to see my screen, guys. So infix expression, or rather say prefix expression, infix expression, and then postfix expression. If my screen gets stuck, you can please let me know. So we have three types of expressions. So if I have an operand compulsory between two operators, this is called as the infix expression. If there is no operand between two operators and the operand has shifted towards the left, not all the operands, even if you have one pair of operators which don't have a even one pair of operands you have which don't have any operator in between, and the operator has shifted towards the left, that is called as a prefix expression. Okay, so let me do this. So I just try to solve it. I'm just randomly just giving you all some. Maybe this should be the plus and divide here. So this, okay, there should be a multiply also, plus star. Okay, there are four of them, right? So let's say I put a star also. One, two, three. So when there is no operator between two operands and the operator has shifted towards the left, is called as a prefix expression. And when there is no operator between two operands and the operator has shifted towards the right, okay, the order has to be maintained. Okay, so plus and star. So plus has shifted towards the right. This is called as a postfix expression. So to convert infix to prefix, and to convert infix to postfix also we use stack. So in application areas of stack, we have convert infix expression to a prefix expression. Second is you can convert a infix to a postfix. Third is once you have converted into a prefix, then we have to evaluate the prefix. That is what is my agenda for today. Prefix evaluation. Evaluate prefix expression, and then we can also evaluate a postfix expression. So this is what I plan to do today. And for that, we will be needing stack. So understanding of stack will be very helpful. Now, how do we convert infix to a prefix? Let's say I have a expression. Okay, you can give me any expression. So let's say I have this expression. A multiplied by B divided by C plus D minus E. Okay, let's take this as expression. So for that, we have a table, operator priority table, we call it. Operator priority table. So highest priority is given to the operator raised to and dollar, which has highest 3 priority. Then your modulus, multiplication and divide have priority 2. The plus and minus have the lowest priority of 1. So these are the operator and these are the priorities. Okay. So if I need to convert a infix expression into postfix, so I will read the expression from left to right. I'll read the expression from left to right. Whenever I will come across any operand, I will directly display it. And the operator I will put on the operator stack. The operator I will put on the operator stack. And I'll read the expression from left to right. Okay, what I'm doing? I'm doing now infix to postfix. This is what I'm trying to do. So first expression I will read is A. What is A? Operator or operand? If it is operand, directly you have to display it. Directly it goes to display. Next, what will come? Star. Next I'll have is asterisk. Asterisk is the operator. It goes onto the operator stack. Next, what do we have? B. B is the operand. Directly goes to display. Next, what do we have? Divide. Now you have to check if the priority of the incoming operator is greater than the priority of the stack. So is divide having greater priority than star? No, they have same priority. Then whatever is in the stack will be popped out. So you can only push when the incoming operator has greater priority. Else we need to pop from the stack. So compare the priority of the incoming operator with the priority of the operator in the stack. So divide with star is, if divide is greater, then you can push. Else we have to pop from the stack. So divide is equal, so I cannot push. So I will pop this. So I will have to pop. And now as there is space, this star will come inside. This divide will come inside. And star has been popped. Next is C. C is a, so in the stack I have divide. C is operand A, B, C, A, B star C. Next is plus. Now plus compared with divide, is it greater? Plus is 1, divide is 2. No. So divide will be popped. A, B star C, divide, and the stack becomes empty. Now plus can go inside. Next, what is coming? Next, we have D. Okay, this has plus A, B star C divided by D. And next, what do we have? Minus next we have minus. So minus will be compared with plus. Is it greater? No. Then plus will be popped. So A, B star C divided by D. Plus comes out and minus goes inside. And last we have is E. And is E is a, in the stack has minus. And as E is a operand, will be pushed to the stack, to the display. Still will be A, B star C divided by D plus E. Okay. And now there are no more left. So this is over. We will empty the stack. And stack will be popped up. So we'll have A, B star C slash D plus E and minus. So this is my postfix expression. Their postfix expression. If I would convert the same to prefix, okay, this. If I convert the same to prefix, okay, I'll take the same three things. Okay. Let's convert the same expression to a prefix expression. So let's take the same three things: expression, operator stack, and display. But now in case of your prefix, you need to read the expression in the reverse order. Okay. From right to left. So what do we read first? So first we will read T. Now T is an operand. I'll directly go to display. Next we read minus. Minus is the operator. You go to the stack and T is in display. Next I'll read D minus ED. Next I'll read plus. Here, if the incoming operator is even equal to, we can push. So minus and plus are equal to, so plus can go inside. Next I'll read C minus plus EDC. Next divide. Divide is greater, will be pushed. So if you are in prefix, if the incoming operator is equal to or greater, we can push. So we can push. EDC. Then D. Minus plus divide. EDCB. And then we have star. Star with divide is equal to, we can push minus plus right star EDCB. Okay. And then we have A. We have minus plus divide star EDCBA over, as this is the stack, empty the stack. So stack means last in first out. So EDCBA star will come out first, then divide, then plus, and then minus. And once we have got this, display the whole in reverse order. Minus plus divide star, and this is my equivalent expression. Okay, this is my equivalent postfix expression. This is my equivalent prefix expression. Now, once you have converted them, now we have to evaluate. So this is what code I am going to show today. How to evaluate a postfix or prefix expression. So if I number these variables, so let's say if I number A as 5, B as 20, C as 10, okay, and D as 4, and E as 2. So if A is 5, B is 20, C is 10, D is 4, and E is 2. If I do this calculation on the calculator, what would be the answer? So as per board mass, I have to do the division first. So it would be 5. Okay, you all do the math. So 20 divided by 10, that will be 5 into 2 plus 4 minus 2. Okay, so if solve this first, 20 divided by 10 gives me 2. So 5 into 2 plus 4 minus 2. B or D. Then we do the multiplication. So 10 plus 4 minus 2. And then 14 minus 2, 12. So the answer of this is 12. So if this expression, if I feed this, answer is 12. So if I evaluate this postfix expression, I should get 12 as the answer. If I evaluate this postfix, because this postfix is the equivalent of this infix, so it should give me answer as 12. And similarly, if I evaluate this infix also, this prefix, it should also give me the answer as 12, because this prefix is the equivalent of this infix expression. So how will I take the expression from the user now? So I'll take the expression as, okay. Okay, so let's first say for the ease of the calculation, let's take single digit numbers. That will become easier in calculation. Okay. So let's take single digit numbers so that we don't mess up. So let's say I call this as 8, and this I'll say as 4. So division becomes easier. So let's take this, and D, we can take 3. We can take D as 3. Now can you all calculate this? So first we'll do the division. So we'll write 5 multiply by 4 divided 8 divided by 4 is 2 plus 3 minus 2. Okay. Then let's do the 10 plus 3 minus 2 So this will give me 11. Okay. So the answer of this is 11, not 10. Okay. So we will try to evaluate this using stack, and let's see if we get the answer as 11. Okay. So what would be the expression which I would enter now? So now I will not enter A, B, C, D. Now I'll enter the proper values. So I'll enter A as 5. So I'll enter 5, B as 8. So 5, 8. Okay, I'm looking over here. So here, 5, 8, star. C is 4. 5, 8, star 4. And divide. D is 3 plus E is 2 and minus. Okay. So after replacing A with 5, B with 8, C with 4, D with 3, and E with 2, I have 5, 8, star 4 divided by 3 plus 2 minus. Okay. So we'll try to evaluate this expression. We'll give this input as a postfix, and we'll see what output we get. And similarly, if I want to give the prefix as input, what will I give? Minus plus, what is A? 5, 8, 4, 3, 2. So if I give these two expressions as an input to my application, it should evaluate both with the answer as 11. Same. This answer should be 11. Because these two are equivalent to this infix, the answer we have found is 11. So how to evaluate a postfix? Let me just show it to you all. So make some space. Also create some space. Can show it to you all clearly visible. If I try to shrink the page, maybe. Okay, so here we'll have the expression. Okay, and now here we will have the stack, and here we'll have the calculation. Okay, so as it is a postfix, we'll read from right to left, from left to right rather. So I'll take 5. Okay, and push whatever element I'm getting, push it onto the stack. Next, I'll get 8, push onto the stack. Now, whenever you get an operator, okay, sorry, how to push it? So first we have 5. 5 goes onto the stack. Then we have 5. Then we have 8. 8 also pushed onto the stack. So 5, 8. Now, whenever you come across any operator, you have to pop this. Okay, so I'll pop the first element. Okay, so this element will be my popped one. Okay, my pop 1 is 8. Okay, so I'll pop this out, and my pop 2 will be 5. So I'll pop the 2 elements at the top of the stack. Whenever I get any operator, I'll pop the 2 elements at the top of the stack. So first I'll pop 8, and then I'll pop 5. Okay, so the first element which you are popping is in this. So the way it is written in the stack, you have to put it like this, same as it is, 5, 8. So you should get 5, 8 over here. same. You'll have to put it same. Okay. So we'll put it like this. So first, it has to be as it is, left to right and left to right, the order which it is over there. So I'll pop the first one. Okay, so here the first one will be 8 and the second one will be 5. So be careful with the variable name. So first element which will pop will go into pop 1, and then second which will be pop 25. And then we will put this operator in between them. Put this operator in between them. So what is the answer? 5 multiplied by 8, 40. And we will push the answer back onto the stack. This is what we will do now, okay? Be with me now. So next what we have? 4. If you have any number, you can keep on pushing that. So 40 and 4. Okay. 40. Now 4. Then comes divide. So what I'll do is, I'll take them as it is, okay? So I'll take them as it is. So first, what is being popped? Okay, first, what is being popped? 4 will go in pop 1. And what is being popped? 40. And now put this operator in between them. So 40 divided by 4. What is the answer? The answer is 10. So that will be pushed back onto the stack. Whatever answer is there, answer will be pushed back. So 10 will come back over here. The next I'll have 3. So 10, 3. Okay. Then we'll have plus. So what happens is, these two will be removed. Pop 1 will have 3. Pop 2 will have 10. I will put this operator in between them. This is the operator plus. What is the answer now? 10 plus 3, 13. And the answer will be pushed back onto the stack. And next what we have? Plus. And we have 2. So 13, 2. And then we have minus. So we'll remove them. Okay, 3, 2 comes in pop 1. And 13 comes in pop 2. The 2 comes in. And 13 comes over here. Put the operator in between them, minus. And the answer is 11. Now this is over. And this is my final answer. So like this, we will get the answer as 11. Same thing if you wish, you can apply it over here for the prefix conversion also. Okay, I'll just shift it towards the left. Okay, so let's try to do the same for the prefix as well. Expression, stack, and calculation. The left little bit. But we have space. That we have some space for the calculation. Okay. So how do we read the expression from? Okay, yeah, right to left, right? But it's a prefix one. So I'll read 2. 2 is not an operator. I'll push it to the stack. Next, I'll read 3, not an operator, push it to the stack. And I'll read 4, not an operator, push it to the stack. Then I'll read 8, not an operator, push it to the stack. I'll read 5, not an operator, push it to the stack. Then I have a operator coming in. So once we have operator coming in, we'll pop the top 2 of the stack. So we'll pop the top two, but in the reverse order. Okay, but in the, so 8, 5 will become 5, 8. So first, what I am popping 5, that will go into pop 2. Okay, that will be in my pop 2. And then what I am popping, so 5, 8 will become 8, 5. So you have to pop it from the reverse order. Okay. Pop it in the reverse order. Extend it over here a little bit. Makes sense. I think use the space. Okay. So now 5, 8. So we have, so I'll pop 5. So pop 1 will be 5. Okay. So that will come over here. And next I'll do is pop 2. Pop 2 will be 8. Okay. So here we have pop 2 and pop 1. So here pop 1 is 5, and then put the operator in between them. Put the operator in between them. 5 into 8, 40. Push the answer back. So what were popped? 2, 3, and these were popped, right? So when I push, I'll push back 40. The next operator is divide. Okay. So we'll remove 40 and 4. Okay. In the reverse order, we will remove 40 and 4. Put the operator in between them. Answer is 10. Push the answer. So 2, 3, and 10. Next, which is the operator? We've done with multiplication, we've done divide. Next with plus. Okay, so remove 3 and 10 will become 10 and 3. And you will reverse 10 minus 3, 10 plus 3 rather. So 13. So 2 comma 13. The last operator is minus. So it will become 13 minus 2. Answer is 11. Over. And this is your answer. So now my question is, we'll write a program to take a postfix as an input and try to evaluate that postfix. Okay. So let's get into the coding part. Okay. Let me know once you are able to see my Eclipse screen. So let's come over here. New class postfix evaluation. Okay. So we'll take a string expression. Okay. Or with other, I can say a postfix expression. Okay. So let's take that expression from here. It's 5, 8 multiply 4. 5, 8 multiply 4. Multiply 4 divide by 3 plus 2. By 3 plus 2. And minus. This is my expression. And then I'll call the evaluate function and pass this expression. Okay. And that will give me the result. which I will eventually display. Okay. Now let's try to create this. Okay. So once I've got the postfix expression, we'll try to see every character has a ASCII value, right? You know the ASCII values of characters? Let me share my screen and show you all the ASCII values of characters. Every character has a corresponding ASCII value, correct? So let me open up the let me share my screen and show you all the ASCII characters. So if I have images over here, so let's check this out. So see the numbers. See, capital A has ASCII value of 65. One has ASCII value of 49. And 0 has ASCII value of 48. Okay, so character 0 has an ASCII value of 48. So if I fetch any character and I minus it with 0, so if I fetch, let's say, character 9, the ASCII value is 57. If I minus with the ASCII value of 0, it gives me 57 minus 48, which is 9. Okay, so to read any character, we need to subtract that from the ASCII value of 0. Is my screen visible to you all, guys? Is my Eclipse screen visible? I'm trying to share my Eclipse screen. Let me know if it is visible. So now I'm sharing my Eclipse screen. Is it visible? Let me know, guys. All good? What happened over here? Okay, let's again take the string. So string postfix expression. Okay. Go to postfix expression. 58 multiplied by 4. 58 multiplied by 4. Divided by 3 plus 2 minus. 58 multiplied by 4 divided by 3 plus 2 minus. Okay. We'll need to evaluate this. So we call the evaluate function and pass the postfix expression. Okay. And then we can sys out the result. Now let's go and evaluate this at the evaluate function. Okay. This will return an integer in return, correct? So my Eclipse is visible to you, all right? So let's try to. So I'll push all them into a stack of integer. I'll push all these numbers into a stack of integers, right? So I'll call that as a stack. Control Shift O. Okay. And then what we'll do is run a for loop and take one character from this expression. Okay. And we'll try to check whether it is a digit character or not. Okay. We just need to push the digit characters in the stack. So if this CH is a digit character, so we say character dot is digit character CH. Okay. That for loop. So if it is a digit character, so what am I reading first? I'm reading 5 is 5 a digit character. Now it has read this 5, right? It has read the character 5, but I need to push the number 5. So what I do is I minus the ASCII value of character 5 with 0 and push that. Okay. So in the stack, I will push is the CH minus with the ASCII value of the digit 0 and then continue. So if there's nothing to be done, so once I get 5, push onto the stack, continue. Once I get 8, push onto the stack, continue. Okay. If I come across a multiplication, okay, then we'll have to do the popping, right? So how would we pop in our postfix? Okay. How would we pop? So I'll put in the operand 2 and operand 2 will come first, right? Operand 2 will come first and then operand 1. So if there is no digit character, if I get her operator, I'll do what were we doing over here? If you'll remember, first pop 2 and then pop 1, right? The same we'll do over here. Okay. So let me write that. So integer pop 2 will be stack dot pop. Okay. And then integer pop 1 will be, so I'll pop both the elements from the stack and then we'll see what type of character it is. So we'll switch the character. We'll switch the CH. Then depending on the case, if it is a plus, what would we do to that? We would do the plus on pop 2 and pop 1. Okay. So whatever operands we are getting, and we'll do the addition and put the addition back onto the stack. And we'll do a break. Okay. Similarly, for the remaining plus minus, I'll do the minus. For multiplication, I'll do the multiplication. And for divide, I'll do the divide. Okay. And then once this is my switch, and this is my for loop, right? And once my for loop finishes, I'll just pop the element which is there at the top. But at the end, the stack will have one element. I'll just return that last element with whatever returns. Okay. So this looks good to me. Let's see if we can get the answer. And here is the answer 11. Okay. Guys, is that making sense to you all? Answer is 11. The same logic we can apply if you want to evaluate a prefix. It's just that the prefix evaluation. You go to prefix evaluation. I have to give a prefix string. So who remembers the prefix string? Prefix string was minus, plus, divide, multiply. Minus, plus, divide, multiply. 58432. 58432. And this will be my prefix expression. Okay. Go on to the prefix expression. Character by character, we'll read it. Okay. And now we'll just do the reverse. Okay. First, we'll take in pop 1. Second, we'll take in pop 2. That's okay. Let's see if we can get the answer for this. Run as Java application. Okay, this is giving me a stack empty. Maybe we line number 24. So prefix explanatory character is digit and push onto the stack. Is everything good? Prefix expression 1, 2, 3, 4. Okay, so here, okay, here we'll have to check because at the start we'll not be pushing, right? So we'll have to check what logic suits over here. Okay. The same logic we've done over here. Character is digit. If it is a CH, push it onto the stack and continue. Okay, we are trying to pop from a empty stack because so we are continuing only, right? So if I get minus, it is not a character. Okay, so I have to check out over here. So if it is first character, it will not go over here. So condition will become false. We have to push and then go, right? Okay, guys, let me check this out. Tomorrow we'll try to complete this. Okay. Running out of time for these 1 hour sessions. So tomorrow, first thing, we'll try to troubleshoot this and we'll start with the next data structure. Okay. So we've finished sorting, queues and stack also is done. Okay, Amar sir, we can call it end of the day. Amar sir. Oh, yes, sir, we can end it.
Thank you.